All right, so looking at geometric probability, let's do a little bit of review. A point indicates a location and has no size. Do you remember if that's true or false? That is true. It has no depth, no nothing. It's just a location, period. Number 2, a line contains a finite number of points. What does finite mean? Can you count the number of points that are on a line? No. So it actually contains an infinite number of points, so this is false.
We don't say infinite.
Why don't we say syllabuses and instead we say syllabi? I don't know. Radius, radii. I don't know. I wasn't in charge of the English language. The English language has some very confusing rules to it. All right, so number 3, use the diagram at the right. Circle the segment that includes point S. Is it PR? Yes or no? No. Is it PT? Does PT include the point S? Yes. How about QR? No. Okay, that was tough. Then probability. What's really important is the probability of an event is the likelihood that the event will occur. And really, this is the important part right here. This is theoretical probability. You want to highlight this. When we find, because we're going to find probability with geometry-related items. So you're going to take the number of favorable outcomes, so maybe that's an area, maybe that's a distance, and divide it by the total number of possible outcomes. So look at number 4. Underline the correct words to complete the sentence. The probability of an event is the ratio, fraction, of the number of blank outcomes to the number of blank outcomes. So what goes up top? Favorable, and what goes on the bottom? And I want you to put total possible. In number 5, there are 7 red marbles and 3 green marbles in a bag. 1 marble is chosen at random. Write the probability that a green marble is chosen. So what you see here is some new notation. This capital P means probability of a green marble. So it's just shorthand notation. So we're going to write as a fraction. What is the total number of marbles? So total is equal to 7 red plus 3 green, which equals 10 total. Where does that 10 go? The top or the bottom of the fraction? The bottom. And favorable in this case is going to be green marbles, because that's what we want to happen. So if we write it as a fraction, how many favorable green marbles are there? 3 out of how many total marbles? The 10. So that's our fraction, 3/10. How do you write that as a decimal? 0.3. And as a percent? Move this over 2 places to the right and add a 0, so we end up with 30%. All right, so look at the next page. Key concept, probability and length. So we're going to look at a number line right here, and we're going to find what is the probability that you would select a point that is in between BC on this line segment from A to D. So this is a distance over a total possible distance. And so right here is favorable over total. So our favorable distance is the BC. Our total distance is from A to D. And so here they say, what is the probability that point S is on line segment AC? Well, there is no point S on here, but we're saying what is the probability that point S would be in between B and C. And so our distance from B to C is BC. Oh, I'm sorry. I just read that wrong. It's on AC, right? So they want to know what's the distance, or what's the probability it would be from A to C, from here to here. So you would just have AC here. So remember that notation without anything above it means the measure from A to C over the measure from A to D. So you write number 7. The probability that point S is on line segment AB. What's in the numerator? AB. What's in the denominator? AD. So probability in area, again, you're going to have favorable over total. You're going to have all kinds of different weird looking or normal looking pictures. So this is just one picture right here. So you have the area of the whole region where a point could be, but they're saying this is the favorable region. They could say that this is the favorable region here, just the greenish blue, or is it the yellow? So look at how they've written it. What is the probability that S is in region N? So region N is the favorable region. So why don't we put N up top? What's going to be on the bottom? What's the total possible region? R. Isn't region N inside region R? Yeah. So region R is the total area. And then if, and they've given us some values here, if the area of region R is 11 centimeters squared and the area of region N is 3 centimeters squared, we can actually figure out what that is. So it's equal to, N is 3 centimeters squared, and R is 11 centimeters squared. Boy, they were tricky, putting them in reverse order. And so the centimeter squared completely cancels, and the 3 does not cancel into the 11, so your answer is 3 over 11, or you can use your calculator and turn that into a decimal. 3 divided by 11 is 0.27, and the 27 repeats, so you put your repeat bar over that. Yes? I prefer fraction, but just pay attention to the directions and see what they want. And because here you have a repeating decimal, so we can write that, but the minute I turn this into a percent, now I'm going to take this decimal point right here and move it 2 places to the right. Anytime you convert a decimal to a percent, you move the decimal point to the right. We're multiplying it by 100, and I get 27. What follows my decimal point now? 27, 27, 27. So the exact answer would be 27.27 repeating percent. Yes?
Even if in like 8 spots there's a 3 explode.
Oh, so this is a good question. So on her calculator, so here's my calculator. So on her calculator, it at the end of her display, she has an 8 because your calculator, did you end at a 2? Sorry. So your 2 got bumped up to a 3 because it knew, your calculator knew a 7 followed it. And on your calculator, because she's got just a little scientific, her calculator rounds that up. My calculators, you can see the graphing, they don't round. So you need to realize that it really didn't round to a 3. It's because your calculator's only going out to like 8 places or whatever it is. Does that make sense? Yeah. So any other questions on that? All right, so let's mosey along. So for problem 1, we want to know point H is somewhere from S to T. So point H is somewhere from S to T here. Do you see point H anywhere there? No. They're saying it's somewhere there. It's selected at random, and they want to know what is the probability that H lies on line segment from S to R. So from S to R. So what's the favorable region? Yeah, so the favorable region, that's why they've got the length of SR here. The favorable region's SR, and the total region is what? ST. So we've got ST here, the distance from S to T. So to find the length of SR, you could count, and you have to be careful sometimes because look here. Every hash mark is going by 1s, but sometimes the hash marks are going to go by 2s or by 5s, so you have to be careful with just counting hash marks. But on here, they're using our subtraction property. S is 2, R is what? 8. So we're going to put 2 minus 8, which ends up being the absolute value of -6, doesn't it? What's the absolute value of -6? 6. So we could have counted, 1, 2, 3, 4, 5, 6. You could have done that as well. And then you find the length of ST, the whole distance. Isn't the absolute value of 14 minus 2 12, or 2 minus 14? Absolute value of negative 12 is 12. And so that's what we're going to put here. We're going to put our 6 over our 12, which reduces to 1/2. So if I were to convert that to a decimal, what's 1/2 as a decimal? And then convert that to a percent, I would move that decimal 2 places to the right, and I'd have to add a what? A 0. So I would get 50%. But most of you know that 1/2 is 50% anyway. So that's not so bad. Using segments to find probabilities. So this one says a commuter train runs every 25 minutes. Every 25 minutes a new train comes along. So if a commuter arrives at the station at a random time, what is the probability that the commuter will have to wait no more than 5 minutes for the train? So they're going to walk you through it. Circle the time in minutes before the train arrives that the commuter will need to arrive in order to wait no more than 5 minutes. So will their time be, so from the time that they arrive till the time that the commuter train leaves, what represents no more than 5 minutes? Does this represent a time from 0 to 5 of 5 minutes? 5 minutes, 5 minutes. If you look at the difference of all of those, they're all a difference of 5 minutes, right?
Yeah.
But which one shows the time frame at which, when you arrive, the train would have arrived within 5 minutes? Wouldn't it be this one here? Because if when you arrive, the train comes within 5 minutes, that means that you must have arrived somewhere between the 20 and the 25th minute of when the last train had left. Does that make sense? All right, so we're going to use that, and then go to your next page. Oh, so no, the wrong one. All right, so then on 13, did I miss something? Oh no, okay, just checking. On 13, you're going to circle the diagram that models the situation. So remember, we were looking at t is less than, was it or equals to? What was the inequality sign?
It was 20 is less than t, and t is less than or equal to 20.
Okay, that's what I thought. Less than or equal to 25, and then 20. Oh, well, that's perfect. There you go. Okay, so which of these diagrams represents this right here, from 20 to 25 minutes? Is it this one, or this one? The third one? How? That's from 0 to 20, right?
What does the red show?
The red is showing your favorable time.
Oh, so it would be the second.
This is showing from 0 to 5. This is your wait time, right? This is your wait time versus the total time that you would be there. So here you're waiting from 5 minutes to 25 minutes. Here you're waiting from 0 to 5 minutes. Here you're waiting from 0 to 20 minutes. So it has to be the second one, doesn't it? Because I only want to wait 5 minutes. So the length of your favorable segment is 5 minutes. The length in the entire segment is what? 25 minutes. Find the probability of waiting no more than 5 minutes. Well, the length of the favorable segment is 5 minutes over the 25 total. Oh, I think they skipped. Hang on.
What's that weird little curve?
I think they're having a little bit of, because you might have noticed that on the 10.6 and 10.7, I think they're having a little printing error. And so they should have put here the ability to do 5 out of 25 first, which equals, what does that reduce to? Or maybe not. I'm not sure what they meant to put there, to be perfectly honest. But it reduces to 1/5, doesn't it? So if they wanted it in terms of decimal, what's 1/5 as a decimal? 0.20. I'm going to put that there for chuckle's sake. And then or, if I convert it to a percent, I'm going to move that decimal 2 places to the right, and I would have 20%. So therefore, the probability of waiting no more than 5 minutes for the train is 0.2 or 20%. So look at problem 3. A triangle is inscribed in a square. So here's that triangle. Point T in the square is selected at random. So somewhere point T is going to be selected at random. It could be in the triangle, it could be over here on this shaded part, or wherever, but it's somewhere within this square region. What is the probability that T lies in the shaded region? So either here or here. So I have to find the favorable region is the shaded part. So didn't we just spend a section trying to find the shaded region? How do I find the area of the shaded region? Here and here. Pretend like this is a cake.
Find the area of the square and find the area of the triangle.
Perfect. So you're going to find the area of the square, right? So it's a square cake. And you're a hog. You took this big triangular piece out of the middle and took it away. Brody, yeah, right? Brody, you did that, Brody? And so everybody else is left with these pieces. So you're going to take the area of the big and subtract out the area of the smaller piece. And what's left are those shaded regions. And so that's what they're walking you through here. So we're going to find the area of the square, area of the triangle. So area of a square would be the 5 inches, because that's your side, right? 5 inches by 5 inches squared, minus 1/2 base times height, right? The reason why I stopped there is do we know the height of the triangle?
Yeah.
We actually do. Why?
It's the same height as
It's the same height as the height of that square, isn't it? I can move this over to here and they'd be identical heights. So let's go ahead. No. Oh, it won't let me get rid of it. Okay, fine. So I've got 5 squared here, and then this is 5 inches. So I've got 5 inches here, and then again we said that this was also 5 inches. So then I have 5 inches here. So to finish it, I like A instead of S. Oh, well, it's because it's the area that's shaded, but we'll go with that anyway. So A is equal to 25 minus 1/2 of 25. So this is equal to 25. What's half of 25? 12.5, which equals what? So that's the area of the shaded region, area of the shaded region. Then they're going to walk you through the probability. So number 19, find the probability. If point T is in the shaded region, remember our favorable is the shaded region, and our total region is the area of that square. So the area of the shaded region is what? 12.5, which you can't have a decimal and a fraction, so we'll deal with that in a minute. Over the area of the total, what's the area of the square? 25. Well, let's think about this logically. 12.5 compared to 25 is what? Isn't it half of the 25? So we end up with an answer of 1/2. So it's not an or. You cannot write 12.5 over 25. That's not an acceptable answer. So 1/2 isn't that 0.5? Or what percent? 50%. Now we're going to use area to find probability. So one of their favorite examples is a dartboard, because it has concentric circles that have different radii. So, this, whoops, didn't mean to write on that, sorry. So this right here, the yellow circle has a different area than the red circle, than the blue, than the black. And those outer circles are actually They're not full circles, are they? They're just like rims, or however you want to call it, partial part of a circle. So look what the question says. An archery target has 5 scoring zones formed by concentric circles. The target's diameter is 122 centimeters. So from, let's get a color that might show up, from here to here, that's, oh, actually from here to here, because I said diameter, right? So all the way across, that's the 122, all the way across. The radius of the middle zone is 12.2. The width of each of the other zones is also 12.2. So what they're saying is the radius of that yellow circle is 12.2, and every distance of each of these right here is also 12.2. So you go 12.2, 12.2, 12.2. So the radius of the target is, we're going to take that 122, that's the whole diameter, 122 centimeters, and divide it by 2. What do I get? What do I get? 122 divided by 2. 61 centimeters. So that's the radius of the whole target. So find the probability. Write the probability as a decimal. So the probability that the arrow hits the middle zone. So I have to find the area of the yellow part of the target. So the area of the middle zone, which is yellow. So that's the yellow over total. So here's where they're weird, okay, this is their weird notation, but this is the probability of the area of the middle, which isn't that's supposed to be pi. So I don't know if it's supposed to be looking like a p or a pi, but you need to change this, because remember, area of a circle is equal to pi r squared. So this little symbol that keeps showing up weird is actually a pi. So you need to fix that. So pi times the radius of that yellow is 12.2. What's the radius of the whole entire region? The 61. So we're going to put 61 in here and see what we get. And so don't use pi. I mean, don't multiply pi in there. Just take the 12.2 and square it, and we get 148.84 pi, and it's centimeters squared, but that's going to cancel out, over the 61 squared is 37.21 pi. So what happens to the pi? They cancel out. So that's why I said don't multiply the pi into there. And so then you're going to reduce this. You're going to have to learn how to use the a lot of you have this button on your calculator, A and then B/C. That's going to help you reduce big fractions like this. And so later I can show you how to use your calculator with that. And oh, terrific. I missed an important phone call. How did that not happen? How did I not hear my phone ring? Anyway. So if I put this in my calculator, 148.84, and I'll show you in a minute here on your graphing calculator. Okay, so we end up with, this reduces to the fraction 1, oops, as my iPad is jostling. This reduces to the fraction, it jostled, 1 over 25. And they want you to explain why the calculation with p is not an estimate, because this is your pi. Because pi is exact. Pi is exact. It's just all there is to it. So the probability that the arrow hits the middle zone is 1 in 25, or remember that decimal was 0.04, and what would the percent of that be? If I move this 2 places to the right, it would be 4%. So it's a 4% probability that you hit the middle of that target. All right, we're not going to do the lesson check, so we're done.